In lesson 9.4, we're going to take a look at different data displays and when to choose which one. So which one is the best representation for your data that you have, and which one would allow a reader to interpret it appropriately. So we have a whole bunch of them, and I'm going to pull up a list here. We've got pictographs, which you've talked about in last year, or if you had me in general math, we definitely talked about this in that class, where we use pictures to represent the data. Then we have bar graphs, which can show data in specific categories. So maybe how many people's favorite color is orange, how many people like green, blue, those are our categories. We have a circle graph, so if we want to look at the parts in comparison to a whole, so maybe what percent of kids like purple, what percent like green, whatever, we're comparing it to the whole. A line graph allows you to see change over time. So when we're looking at two variables, how does it change over a length of time? A histogram shows the frequency of values in an interval. So maybe I might look at the number of students in age ranges 9 to 12. So that would be my interval. A stem and leaf plot, we put the numbers in numerical order, and it just allows us to see where there are clusters or maybe where there are gaps, like we've talked about earlier, or outliers. A box and whisker plot allows us to see how the data is spread apart or clumped together. And it also allows us to see how the data is split up into quartiles. So the data is split up into fourths. So is the lower end of the data clumped together, or is it really spread out? It just allows us to see that variability or that spread within the data. We've got a dot plot so we can see how many times something occurs. So maybe we have a number of kids who are 8 years old or something. We would have that many dots to represent that there are that many of them. And then the scatter plot, which is what we have been talking about this whole chapter 9 so far. So we're going to take a look at just some examples of different data and what kind of graph you would recommend for each of them. So in this first one, we got some roadkill. A group of schools in New England participated in a 2-month study. They reported 3,962 dead animals. Of them, 307 were birds, 145 were amphibians, 2,746 were mammals, 75 were reptiles, and they could not identify 689 of them. Now think about this. I know the total number of dead animals, the total number of roadkill, right? It's 3,962. So if I am looking at a whole group here, and then I've got all 5 of these parts, I am looking at a part to whole comparison, right? So if we go back to our list, we are looking at the parts of a whole. So a circle graph probably would be the best fit because we'd be able to break down and see what percentage of each there are. I've had kids say that bar graphs in the past would be good, and I could see your reasoning for that. But I'm going to go circle because the circle allows me to compare it to the whole. The bar graph would focus more on comparing them to one another. So how to make a circle graph? Go with it. Pretend it's a nice perfect circle. We have to calculate the percent that each of these is. So for the birds, we have 307 birds out of 3,962 dead animals. So I'm going to go ahead and calculate that as a percent. 307 divided by 3,962, and we get approximately 7.75%. I'm going to go to the nearest hundredth for my percents. Okay, I want you to do that for the rest of the 4 sets of animals and calculate the percent, round them all to the nearest hundredth. All right, so I calculated all my percents to the nearest hundredth. Now, a way to check myself and make sure that I know what I'm doing and that I'm on the right track is to add up all my percents, because what should they all be total? They should all be 100%. And in fact, if you add up all 5 of these numbers, we get exactly 100%. Okay, now what to do next? We could bust out a protractor to help us figure this out, but I say we probably don't have those laying around. I don't even have one in my house. I'm a math teacher. So instead, we're going to approximate, all right, get close, to the best of our ability. So a circle has how many degrees in it? 360, right? So 180 degrees would be half of a circle. Well, if we split it in another half, each of these quadrants would be 90 degrees, right? Okay, instead of converting these all to degrees, we're going to just ball. Do you know what about 75 or 70% of a circle looks like? So checking out this number right here, should use blue, there we go. Because 69.31% is about 70%. Well, I know that 3/4 would look like this. If I were to shade all of that in, that's 75% of the circle. Well, I don't want 75% of the circle. I only want about 70. So I'm going to delete just a little bit here. Just a little teeny tiny bit. And we're going to say those are the mammals. So mammals are in blue. That's my key. Now the next one, I'm going to go to the next biggest value, the unknowns. 17%. Okay, I'm going to start from the top because if this little area here is 25%, 17% from here, about there. Right? Close enough. Okay, now 17 plus 8 gives me 25. You with me? 17 plus 8? Because I'm saying this is just about 8. 17 plus 8 is 25, so that's going to give me that little 25 slice of the circle. Now we're getting real small here. 3.66, that's approximately 4%, and then this one is about 2, so I'm going to split, oh yeah, that looks about right, 4, and then this little sliver left here is my 2%. So I know that that is not exact, but that's okay. We could make exact ones if we want, but it's more about the focus of, well, I know I'm comparing a part to a whole, so a circle graph would be the best option. All right. We got some black bear roadkill. Just loving that roadkill right now. We have data collected from year 1993 all the way to 2012. What do you think would be the best data display? So we've got years and then the number that's occurring for each year. Did you say a line graph? Because you'd be right if you did. This shows how data changes over time. We're able to see that relationship and change over time. So I want you to pause and make a line graph from the year 1993 to 2012, and then let's talk about that change over time. All right, so instead of you trying to look at my terrible drawings and me sketch a graph, I chose to make the graph on Desmos, and then I screenshotted it and put it in here. So we can see if we were to connect this for a true line graph with straight lines, right, straight segments between all of the pieces, it shows us the change that's occurring over time, between the number of bears, right? Oh man, struggling. Okay, there we go. And the change over time. So we can see my years down here on the x-axis. Well, what do we notice in general overall? What's the line graph let us see? Hopefully you see that the number is increasing. The number is increasing as the years increase. Why might that be? I want you to think about that. This is where you get to interpret it. What's going on? In years past, I've had kids say, well, maybe more people are driving, so there's more opportunity for cars to hit them. I've had kids say, well, we're getting rid of more forests, which is where the bears live, so it forces them out onto the road. And they're not sure where to go, and that causes more accidents, right? So lots of interpretations that you get to choose for how you see the data and possible causes. The line graph just gives us the nice visual of that. Okay, if you have time, I would highly recommend that you do this. It's just a little mini project where you're looking at endangered species and how it changes over time. So use your phone, use your computer, whatever you've got to research an animal and look at the number or the population from year to year and see how that changes over time. Then make a line graph, right? Because we want to see how it changes over time. So for example here, the Florida key deer. In 1939, Florida banned the hunting of the key deer. The number fell to about 100 in the 1940s. Now, you can see that this fluctuates because we protected the key deer in Florida, right? If you continue to read there. We can see that the population increased to about 800. So sometimes we're able to intervene and help out those endangered species, but other times, and as you will find on the internet, sometimes they just slowly dwindle away till there are none left and they become extinct. So I would recommend you go ahead and look up an endangered species and see how the population changes over time. If you do that, go ahead, write it up and send it to me in an email. I would love to see it. But we're going to pause here and we're going to look at more types of graphical displays in the second video.